наше путешествие по космосу. Чем дальше, тем интереснее. Вы, наверное, слышали высказывание нашего космонавта Юрия Алексеевича Гагарин. Впервые полетел в космос 12 апреля 1961 года. Мы, как россияне, как русские, гордимся этим фактом, что мы были там первые. Когда Гагарин слетал в космос, он сделал такое утверждение, что он в космос летал и Бога там не видел. Наверное, слышали, да? Ну, может быть, да. Нет, ну Гагарин, знаете, что говорил точно? Вот что точно Гагарин говорил, я читал его высказывание, он говорил о том, что он, ну я сейчас перефразирую его высказывание, не дословно цитирую, но он утверждал, что он с таким удовлетворением читает письма людей, которые в прошлом были верующими, но после его полета перестали быть верующими. Вот. Потому что вот Бога не обнаружили в космосе. И на это заявление, ну, может быть, на заявление Хрущева, на самом деле, может быть, это был некий перефраз Никиты Сергеевича, Клайв Льюис очень мудро высказался. Он сказал, что делать подобные заявления, все равно, как если Гамлет сказал, что он у себя в замке на чердаке искал Шекспира и не нашел его. Очень точно было помечено. Вот, ну, а мы с вами будем продолжать смотреть на космос. И для верующих людей космос — это своего рода свидетельство существования Бога. Ведь мы можем смотреть на одно и то же, верующие, неверующие, и совсем по-разному интерпретировать это. И я знаю, что вы пришли сюда не для того, чтобы слушать меня, а для того, чтобы послушать нашего уважаемого спикера. И поэтому сейчас я даю ему возможность сказать. Давайте поприветствуем Ноби Стоуна. Ноби, вот так. About Gagarin. That we will first in space. I will tell you later. Actually, I quoted Clive Lewis. I quoted Clive Lewis. And I'll tell you later.
Okay. Okay, so last hour we looked at what we have observed of the cosmos, and we began to look at the way it may have come to exist. And what we see is that it has not always existed. There's physical evidence, things that we can see and measure, that tell us that the cosmos had a beginning, that's the first thing we find that is in agreement with Genesis chapter 1, the first three words of Genesis, in the beginning, which science for about 1,000 years, from Aristotle to the 19th century, didn't believe. And they did everything they could to find a way to not have a beginning. And, you know, the reason is obvious. If you don't have a beginning, then it's much simpler to explain. And if you are worried about God, you don't have to worry about God if there's no beginning. If it just always existed, you don't have to have a creator. I had a friend, he was a Swede, Hannes Alfvén. He won the Nobel Prize in Physics in 1974, I think. And I never will forget, we're walking out of an auditorium, and he had given a talk, and he says, "I don't like the Big Bang very much." And the reason he didn't like the Big Bang is because he said, quote, "It's too much like God." Well, we'll see. Today, the Big Bang is the most favored theory of how everything came to be. It has some weaknesses though, so we want to look at the logical. Oh, I'm not ready yet. Excuse me one moment. I got too involved in drinking coffee and eating sweets. Okay, so
Выключите звуки вашего телефона, но если возможно, поставьте в режим полета, хорошо? Потому что мы делаем видеозапись, всякий раз, когда к вам идут звонки или смс-ки, это отражается на видеозаписи, идут пометки. Если, конечно, вы ожидаете какой-то очень важный звонок, другой дело, но если можно отключить телефон, то, пожалуйста, вперед.
turn it on. Okay, I'm ready and you're already ready. Okay. So we want to look at what happened in the beginning. Now, since we established last hour that there is a beginning, in agreement with the scriptures, what happened in the beginning? And there are only a few logical possibilities. If we look at them, for example, if the universe is not eternal and it had a beginning, and we looked at last year time, if it had a beginning, then either there are one of two possibilities. Either it created itself from nothing, and actually since time was created in the beginning, it created itself before it existed. Kind of hard to think about. Or it was created by something or someone that existed, pre-existed the universe. So there was a beginning. We've established that. And basically today, all modern science agrees that there was a beginning. The question is, how did it begin? What can we learn of the beginning? So last hour, we saw that we have observed that the galaxies are moving apart. If you reverse the equations of motion that describe the motion of the galaxies and run them backwards, kind of like running a movie backwards or a video backwards, the galaxies, instead of expanding, go back and contract and get closer and closer until they converge on a point. And when people saw this happen, they thought, that must have exploded from the point. It makes kind of sense. And by the way, we observed that the creation began at a single point. If you carry the reverse, the time in the equations and go back far enough, all the galaxies come and they merge together into a single point, literally a point. So we might ask, well, what were the conditions at that point? What would it look like? It's hard to imagine. If you consider the implication, all the mass of the entire universe. Think about the Earth. It's massive, but it's nothing almost. Think about that star Antares that would occupy half of our solar system if it were where our sun is. Well, that's just one star. There are 100 billion stars in the Milky Way and 100 billion galaxies like the Milky Way. And all of that's crammed, and all of that energy and mass is crammed into a submicroscopic point. So what would the conditions be? Well, it would, if you can talk about such a thing, it would be infinite mass and infinite energy on an infinite temperature on a single microscopic point, or in mathematical terms, a singularity. Now, we have, at this point, left our ability to understand anything in physics. So this is beyond the ability of human understanding of nature to explain. The laws of physics don't apply to this point. Needless to say, this would be an extremely unstable point. And if you look at the characteristics of the expansion of the galaxies, something I didn't tell you last time, but we'll look at it a little more, the galaxies are not all expanding at the same rate. Those that are closer to us are moving slower, and those that are further away are moving faster. So the man that discovered this was an American astronomer named Edwin Hubble, and it's called the Hubble constant. It relates the speed of the recession of the galaxies to their distance from us. So if you look at the characteristics of an explosion, the material that was at the center is moving the slowest as it expands. The material is at the edge of what exploded is moving the fastest because it's being pushed by all the material inside of it. And this is exactly the signature of the expansion of the universe. And so they came up with the idea that the universe exploded from this singularity. Okay, that's what I just said. I'm sorry I'm getting ahead of myself again. Maybe I'll wake up a little more tomorrow. So at this point we know that there was a beginning, and the creation began at a single point, and the creation exploded into existence. We ask the question then, is there presently any existing fossil signature of what happened? What would you expect to have happened? We can't go back and look at the beginning. But if that's the way it began, and it comes out, how would we expect things to look now? So, powerful explosions, like a nuclear bomb, there's an initial flash, a very, very powerful, instantaneous burst of energy that will blind you if you're looking at it. And it's one of the things they used to tell, if there's a nuclear explosion, don't look, cover your eyes. There's this initial flash. And so they reasoned that if the universe, which is the mother of all explosions, occurred, there should have been an initial flash. And that it should have been a very, very energetic form of radiation. Gamma rays. So it was predicted as far back as 1948 that the universe had an explosive beginning, and therefore it would have created this gargantuan fireball like occurs in a nuclear bomb, and that there would have been this intense flash of gamma radiation. But we know something else as well. It is hypothesized that space itself is expanding. You see, what came out of this initial explosion, prior to the explosion, from this singularity point, there was nothing. Nothing physical. So that means there was no time, no space, no energy, no matter. All of those four things came out of the explosion. And so space and time came out, space expanded along with the matter. This is the theory of the Big Bang. And that being the case, if space is stretched out, it would stretch out these waves, these gamma rays. And so as you stretch it, the wavelength becomes longer. So let me explain something. Radio waves, gamma radiation, light, infrared, all of those things are physically the same thing. They're electromagnetic waves. They're just different frequencies. Radio waves are very low frequency. If you go higher in frequency, you get to visible light, which we're able to see, our eyes can detect. If you go higher than that, you have infrared, and then you have gamma. At the top, you've got gamma rays, which are the most energetic of all, and the shortest wavelength. So if space expanded, it would stretch out the wavelength, and gamma rays would be transformed into microwaves. So it was predicted back in 1948 that we should detect a microwave background, which is the signature of the initial explosion of the universe. Had not been observed. Some 16 years later, it was observed that there was a microwave background that was consistent with the predictions. And then in 1992, NASA launched a mission. It was such an important question. They launched a mission to study this radiation, the microwave background. And they found that it was absolutely uniform to 1 part in like 100,000. Very uniform, everywhere you look. Therefore, it did not come from individual stars, in which case it would be bumpy, but it's smooth. It came from the initial explosion when everything came into existence and began to expand outward. That's an observation that was made after the prediction, some 16 years, and finally confirmed in 1992. So the mission shows, as I say, 0.001% variation, almost no variation. It matched the detailed predictions of the Big Bang Theory. And it eliminated the smoothness, eliminated the possibility that this radiation came from stars or galaxies. It came from the initial explosion. Are you with me? Okay. So as the universe began to expand, these waves, it was predicted, would not be gamma rays, but they'd be stretched, and they would get wavelength, would get longer and longer, until at the point we are in the expansion today, they would be long wavelength microwaves, the kind that your telephone uses. And that's what was observed, exactly what was observed. So accordingly, the cosmic microwave background, that's what this is called, and you see it wherever you look in the sky, has been broadly interpreted to be the remnants of the primordial fireball from the initial explosion of the universe into existence. And we're obviously beyond physics at this point. Somebody asked a question yesterday about this. I hope they came back. So now we know there was a beginning. There was a creation began at a single point. It was explosive, and there was a primordial fireball, just like you would expect if there was an explosion. The question is, what exploded? You can't have an explosion unless something explodes. And what was produced by the explosion? So we observe that the cosmos exists basically of three things: energy, matter, which are basically the same thing. You know, Einstein came up with the equation E, energy, equals m, mass, times the square of the speed of light. So Einstein's equation relates matter and energy. What it says is they're really the same, different forms of the same thing. Kind of like ice and water are the same thing, they're just different forms. Well, more complicated than that, but energy and matter are different forms of the same. In a nuclear bomb, you convert a little bit of mass into a lot of energy. You convert mass directly into energy according to that equation, E equals mc squared. In pair production, we can go the opposite direction. We can convert energy back into mass. So they're equivalent. So the things that the universe is consist of is matter, energy, which is the substance of the universe; space, which the universe occupies; and time, which is probably the most esoteric of all the three. All three are thought to have originated in the Big Bang, come into existence at that point, and everything in the universe that we see that exists depends on these three: matter, energy, space, and time. The various laws of nature that we know about in science are really just discoveries of the fundamental description of how these three things interact: space, time, and matter, energy. They interact, and the laws of nature describe those interactions according to what we observe. So we have now mass, energy, space, and time are thought to have emerged from the primordial explosion of the universe. And this is difficult to think about, but from nothing into something. So we can ask a couple of questions that are very easy to ask, very difficult to answer. Why is there something rather than nothing? You know, if you start with nothing and you still have nothing, it's not too hard to explain. But if you start with nothing and you end up with something, what's the process by which you create something out of nothing? It's kind of beyond our comprehension, isn't it? And the second question is, why is the something structured the way it is? You see, we observed, and we just spent an hour talking about it, the tremendous order in the cosmos. We have stars. Stars are arranged in galaxies. And around some stars we have planets. And on some planets, or a planet, we have Boeing 77 airliners, Rolex wristwatches, and people. So why is the universe structured? How did all of this come about? Well, the Big Bang Theory is science's current best attempt to answer those two questions. And actually, honestly, it answers neither one. Let me explain. I'll tell you what the basic things that the Big Bang Theory says. If you go in and try to look at the details of it, the mathematics are horrendous. But it's fairly simple to understand the basic idea. The basic idea is that the universe began in a single immense explosion from which all matter, energy, space, and time originated, and that the order that we now see has evolved from that initial chaos. And as we go along, I'm going to distinguish between what we actually observe and what is hypothesized. The first is observed. The second is a hypothesis. And there are problems with that hypothesis. And they're not necessarily scriptural problems, they're physical problems. The theory assumes no external influence. I talked about the philosophy of materialism yesterday. Remember the belief that all there is to existence is the material universe and its laws, that there's nothing outside of that, which eliminates not only God, but self-will, decisions, love, a whole bunch of other things. The theory assumes no external influence. Secondly, the theory does not account for the origin of what it was that exploded. If you're going to have an explosion, you must have something to explode. The theory says nothing exploded into something. We don't have any way of explaining that. The theory appears to violate some very fundamental laws of physics. And that's where I want to go now. Let's talk about some of these laws. There's the law of cause and effect. It can be stated as every effect must have an adequate antecedent cause. So let me explain this a little bit because it's very, very important. This observation is absolutely essential for science to work. This says that the universe is ordered. Things don't just happen for no reason. That if something happens, it has a cause. So, every effect must have an adequate antecedent cause. Let's talk about adequate for a moment because that's important. So, there's a train that goes across Russia. It's called what? The Siberian Express? Is that right? Who? Say again? Trans-Siberian. Gotcha. So let's assume, this is just a make-believe, but let's assume the Trans-Siberian Express is rolling along and the engineer goes a little too fast around a curve and it jumps the track. And the engine goes off and cuts a hole in the ground and all these cars pile up and everything comes to a stop and finally the dust settles and people are groaning and moaning because they're injured. And the engineer's supervisor comes to see what's happened. And he doesn't want to admit he was going too fast around the curve, so he says, well, you know, we were going along below the required speed, mind you. And there was a dog running along beside the track. And just as the engine got up to that dog, a flea jumped off of the dog. Do Russian dogs have fleas? A flea jumped off the dog right into the path of the train. And pow, we hit the flea, and well, you see what happened. So do you believe that? Well, how about the idea that the Earth, the Sun, that huge star, Antares, our galaxy, and 100 billion other galaxies all came from a submicroscopic speck with no cause? It's worse than the flea, isn't it? So every effect must have an adequate antecedent cause. Antecedent means the cause must come before the effect. So where I come from in Alabama, if we have a flash flood, we don't blame it on tomorrow's thunderstorm. We blame it on yesterday's thunderstorm, right? I assume you know what a flash flood is? So, antecedent cause. So this says basically that the universe is organized and things happen for a reason. If you're sitting in the room and you're reading and the door slams and you look around to see who came in, right? Because it's time to get up. So maybe I'll be awake the rest of the time, hopefully. But we understand inherently that things don't just happen for nothing. Doors just don't slam by themselves. Trains don't derail off the track because of inadequate causes like a flea. And the universe doesn't explode without a cause. Let's look at the first law of thermodynamics. This says very simply that matter can neither be created nor destroyed. So let's look at that just a little bit. Let's say the Russians go camping, sleep outside in a tent or something, and it's cold. So you build a fire to keep warm. And you bring up a big 200-pound, 6-foot-long oak log that big around, you throw it on the fire, and the fire burns all night, and the next morning you get up and the oak log's gone. What happened? What happened to all that 200 pounds of mass? There's nothing there but a few little ashes. Well, did we destroy the matter in the log? No, we just changed it. You see, the log wood is made out of hydrocarbon molecules, hydrogen and carbon. And if you get it hot, they come apart, and you have free hydrogen and free carbon, which combines with the oxygen in the air, and it forms H2O, which is water vapor. That's a gas. And it forms carbon dioxide, which is a gas. So that log is still with us. It's just out there in the atmosphere somewhere. We didn't destroy anything. We just changed the form of it. If we have a nuclear power plant and we bring in some uranium to run the power plant, and that matter gets converted to energy, did we destroy it? No. Remember, we can convert matter to energy and energy to matter. All we've done is change the form of it. No matter what we do, we cannot destroy or create the substance of the universe, energy, matter. That's what that law says. But what does the Big Bang say? The universe, all the matter and energy of the whole universe was created without a cause. So, let's look at the next law. The second law can be stated simply as the total entropy of any isolated system can never decrease in any reaction. Now, you all know that. Maybe you don't know it in that terms. But what that law says is that everything grows old. Everything winds down. Everything deteriorates. Everything eventually dies if it's alive. It's kind of a downer of a law. But this law has been observed indirectly throughout human history. And in the later centuries in modern times, engineers discovered this law, more specifically trying to improve on steam engines, the efficiency of steam engines. But today, we understand that this law is almost universal applicable. The universe could not operate without this law. Because of this law, we have heat from the sun. Because of this law, everything we see that happens relates to this law. What this says is that, think of entropy as disorder. If you have a system and you don't do anything to it, it's isolated, anything that happens in that system will create some disorder. So if you take an automobile and you sit it out here in the parking lot for 100 years and you come back, would you expect it to crank? No. The battery would run down, the metal would rust, the tires would develop leaks and go flat. It would literally fall apart. Take me. When I was your age, I was in college, I was a collegiate athlete. Gum. I was a collegiate athlete. I was a gymnast. And I could bench press 300 pounds. I don't know how many kilos that is, but anyways, it's a lot of weight. I could do all kinds of things. You know, today, I have to really work to get out of bed in the morning. Entropy has done its job on me. My hair has turned from dark brown to this white. A lot of it has already fallen out. I don't have muscles anymore. They're sagging. Entropy's done its job on me. Entropy will work on everything. Nothing can escape this. And this law has been looked at in every kind of system we know of. Mechanical systems, electrical systems, biological systems like me. There's nothing that escapes this law. Everything moves from order toward disorder without a single exception that we've ever observed in the history of man. By the way, the cosmos is a closed system. According to the materialist, it's all that exists. So nothing can come from outside and nothing can go outside. The cosmos is it, period. So according to this law, the cosmos must deteriorate. And indeed, that's what science tells us. It says that if we're around long enough, which is a lot longer than we'll be here, the cosmos will continue to expand. Stars will begin to die more rapidly than they're created, they're born. And the galaxies will begin to grow dark. And eventually everything will go into what's called heat death. Everything will be the same temperature, the same density. You could go billions of miles and not realize you'd gone anywhere. It would all be the same. That's what the laws of physics tell us will happen eventually. Let's look at what the Big Bang says compared to that. The red line here is the Big Bang theory. It says we start with a gigantic explosion, chaotic. And given enough time, slowly, this explosion self-organizes and becomes more and more ordered, more and more functional, until finally we have Boeing 747 airliners, Rolex wristwatches, BMW cars, and people. And you all came out of that initial explosion. And it's self-ordered. But what does the second law of thermodynamics tell us? It says we begin ordered, and anything you do creates disorder. If you drive your car somewhere, it has a radiator. Why does it have a radiator? Because the burning of the fuel creates waste energy that you've got to get rid of, heat. And you can't get that back. If you fix a pot of coffee in the kitchen and you let it sit there and the pot grows cold, you can't go around the kitchen and get that heat and put it back in the pot. So it says we begin with order and we always go toward disorder, toward chaos. This most fundamental, most sacred law, all in science, the second law of thermodynamics, is in direct opposite to the Big Bang prediction. You see that? Okay, what happened here? I guess I mashed a button. Excuse me a moment. Okay. All right, so Stephen Hawking, have you heard of Stephen Hawking, the British astrophysicist? He's an interesting man. He's got a debilitating disease, Lou Gehrig's disease. And he was told he would die when he was 26 years old before he got his doctorate. And he decided to go ahead. You've got to admire the guy because he overcame tremendous odds. He's still alive today. He's about my age, I guess. But look what he says. The odds against a universe like ours emerging out of something like the Big Bang are enormous. In his first book, he went on to say, I think there are religious implications. Now, in his second book, he doesn't say that. But his first book explained things very well. His second book doesn't explain anything very well. So he's changed his mind to be true in advertising. But this is what he said when he was writing a very serious book. So, assuming a closed universe, in an attempt to find out how we could begin with an explosion and end up with the day with planets and stars and people and steam engines and automobiles, Roger Penrose, who was a colleague of Stephen Hawking's, did some calculations. And he basically wanted to avoid violating the second law of thermodynamics, which you saw that it does. They're in opposition. So he basically flipped up the curve and said, okay, where would we have to start in order to decay to today's order and not violate the law? So instead of starting down here and going uphill and violating the law, he wants to raise this end of the curve up to where it's a little bit above this one, and you can actually have decay. How ordered would this have to have been in the beginning? And he did a calculation, and I won't go into the details, it's rather complex. But he starts with an entropy that's low enough without violating the second law of thermodynamics. And the question then is, how ordered would it have to be in the beginning for this to happen? He concludes, after some calculations, that in order not to violate the second law of thermodynamics, the precision of the initial condition at the singularity from which everything came would have had to been one part in this number here. And I want to spend a minute explaining that number to you because it's very interesting. Let me explain a scientific notation. I don't know if you all know that, but 10 to the first power is just 10, 1 10. 10 to the second power is 2 tens, 10 times 10, which is 100, right? 10 to the third power would be 3 tens multiplied, which is 1,000. 10 to the sixth power would be 6 tens multiplier, 1 with 6 zeros, 1 million. And so it goes. So if we go up to 10 to the ninth power, we have about the world's population. So in just going from 1 to 9, we go from approximately the number of people in this room, a few tens, up to the population of the world, just going from 1 to 9. So if we look at some other numbers, like the number of grains of sand on all the beaches of the earth, it's 10 to the 21st power. The number of stars in the sky, in the cosmos, is estimated to be 10 to the 22nd power, one with 22 zeros behind it. If we look at the number of atoms in the universe, do you hear what I said? The number of atoms in the universe? You know, if you take a little cup that big, it's got like 10 to the 20 atoms in it. So you think about it, all the atoms on the earth, all the atoms on all the other planets, all the atoms in the sun, all the atoms in all the other stars in the galaxy, all the galaxies, all of those atoms is 10 to the 80th. One with 80 zeros behind it. This number is 10 to the 123rd, but that's not it yet. I'm just explaining what that is. 10 to the 123rd would be the number of grains of sand on all the beaches of Earth times the number of stars in the sky times the number of atoms in the universe. That's how big 10 to the 123rd is. Now, the possibility of this happening is 1 out of 10 raised to 10 to the 123rd power. It's just beyond comprehension. It is a very strong argument that the universe did not have a natural cause, that it was created by something. Sir Fred Hoyle is a world-famous astrophysicist, and he, not a Christian, but he came to the conclusion, he says, a common sense interpretation of the facts suggests that a super intellect has monkeyed, I don't know if you have that expression in Russian or not, fiddled around with physics as well as chemistry and biology. In other words, there is intelligence in the way things are put together. So, what's wrong with the materialistic Big Bang theory? Well, it excludes any external intelligence or influence. It says that the universe must be created within the universe. That's a difficult problem. Secondly, it claims that the mass and energy of the entire universe, as well as space and time, sprung forth spontaneously without cause from a single point. Now, our observations do suggest that they sprung forth from a point, but without a cause. And thirdly, it claims that the presently observed order evolved. In other words, there was a self-ordering, which, again, violates the scripture, and it also violates the second law of thermodynamics. So this Big Bang theory, in its materialistic form, has some serious, serious problems. Not just problems with scripture, but problems with some of the most sacred laws of nature. So, we can strike off created from nothing and look at the last option. The universe was created by something or someone. It's the only other option left. What does Genesis say? In the beginning, God created the heavens and the earth. Let's look at that in a little more detail. And I will offer this as a possible interpretation of this. I can't prove that this is correct, but it is a possible interpretation. If we look at the original Greek words and what they mean, then the word beginning is the word bereshith, which means the commencement of time. The commencement of time. Now that's different. It's not the beginning of the soccer game. That's the beginning of an event in time. This is much more sophisticated. It's the beginning of time itself. Before this, there was no time. That's something we can't even conceive of. And you know what's interesting? This was written by Moses 3,500 years ago. You don't read about it in any human literature until the 20th century in modern science. Think about that. The scriptures are unique in this. Only the scriptures and all literature that we know of up until the 20th century talks about the beginning of time. And it's a concept that's very, very difficult to think about. In fact, if you think too much about it, you will absolutely get a headache. Let's look at God alone. It's talking about the majestic, omnipotent characteristics of God. Created is the word bara, which you may be familiar with. It means God made. Now, it doesn't always mean God made from nothing. For example, the same word is used when God made Adam from the dust of the ground. But almost all scholars will tell you that in this context of Genesis 1, it means God brought into existence, made from nothing, made ex nihilo. Again, the Bible is unique in that characteristic. Nothing else talks about made from nothing. Now let me go back a minute. If you look at any of the creation myths, the Mesopotamian myth, or any other civilization, they always start with something, with water or something like that. They never start with nothing. Only the scriptures say that in the beginning there was nothing and God created something. And what does modern science say? We started with nothing and now we have something. Let's look at the last part, the heavens and the earth. Samaya and Ertz, respectively. The ancient Hebrew language had no word for cosmos or universe. It was unknown to them. So if you're going to tell them that God created the whole universe, how would you say that? Well, you might say He created the all. That would be one way to put it, but not very satisfying probably. And so we have God created the heavens and the earth. Well, what is that? That's everything the ancient Hebrew people could see. They could see the heavens, they could see the moon, the stars, the sun, and they could see the earth and everything in the earth. And when you think about it, that does include basically everything, doesn't it? Maybe not as detailed as modern physics would, but it's everything. So God created everything. There's an article, ETH. When it's placed before a noun, it means the substance of the noun. So if I say the Baltic Sea, you understand this huge body of very cold water with maybe lots of ice on it. But if I say Ertz Baltic Sea, then you're to understand the substance of it, which is primarily water, right? So it changes the meaning of the noun. So when placed before the heaven and earth, it's talking about the substance of the heaven and earth, or the substance of the universe. So let's look at what this possibly could say. In the beginning of time, putting in what we know about the words in Hebrew. In the beginning of time, the majestic, omnipotent God brought into existence the substance of the material universe. And I want you to think about this a bit. If God is the creator, what does Genesis 1 tell us? The rest of the chapter. It tells us that He created things in a sequence, in order. And so the first step of that sequence would be logically to create the substance from which everything else is made. So the initial first step is creating the substance of the universe. The subsequent steps are creating the bodies in the heavens, the stars, the sun, the moon, earth. And then He came and He prepared earth. And we'll look at that tomorrow. And last of all, He created man. That's what the Bible tells us. It does not disagree with what we observe. It disagrees with the assumption of materialistic science, which assumes that the material universe is all there is. But there is more of the universe than material things. A decision is a real thing. And yet it cannot be described by materialistic science. So, God is the Almighty Creator and the author of Scripture. Then our observations of nature and Scripture must be consistent. And the question is, are they? So I want to look at a couple more things. Things we have observed. The cosmos has three prime constituents: energy, matter, space, and time. All thought to have come into existence in the Big Bang. Is that consistent with Genesis 1:1, which tells us that God first created the substance of the universe? And then the rest of the chapter tells us the sequence in which He created everything else. So, the creation in a sequence is consistent with what Genesis tells us. And the first step would have been to create the substance from which everything else was created. I don't see any disagreement there. Secondly, the galaxies have been directly observed to be moving away from Earth and away from each other. Think of it as a loaf of bread with raisins in it. And you put the dough out and it begins to rise. What happens to the raisins that are in the dough? They all move apart, right? And that's exactly what we see in the universe. We see the galaxies being moved apart as the universe expands. So is this consistent, the expanding universe, with Genesis? So if the creation began at a point, then it's not inconsistent with what you would expect. And it's not necessarily inconsistent with what Genesis says. Genesis simply doesn't address what happened after the initial point of creation until later in the sequence. The theoretically predicted cosmic microwave background, that flash of radiation from the initial explosion, has been observed and interpreted to be the primordial flash from the Big Bang, and is consistent with the behavior of waves that we observe in physics. It's suggesting that an explosion of space itself. So the question is this consistent with Genesis 1? Well, we can't say for sure, but we can say that it is not inconsistent. It does not violate Genesis 1. Genesis 1, again, just doesn't address this. But there are some other scriptures that do. You see Job 37:18, when Job is confronted by God finally and asked if he can do certain things, he says, "Can you join him, God, in spreading out the skies?" In Psalms, the psalmist 104 says, "He stretches out the heavens." And Isaiah 40:22 says, "He stretches out the heavens like a canopy." This is very consistent with an expanding universe. The laws of physics are not violated by creation. The initial creation was perfect. God looked at everything He created and He declared it good. So we start up here in perfection. So if we look at that, the Big Bang starts with chaos and has to figure out a way for chaos to order itself. Scripture starts with perfection. So there's no need for chaos to order itself. But things are not perfect anymore, are they? You see, I told you that I was once a college athlete, a gymnast. Today my hair is gray. It's falling out. My muscles are sagging. My teeth are crooked. A lot of things are wrong with me, and probably with each of you. Things are not perfect anymore. Rocks fall out of the sky. One came roaring by, I think, a southern town in southern Russia about 3 years ago. Volcanoes erupt. Storms blow by. Tsunamis flood people. The world is not perfect anymore. So the question is, what happened? Well, let's go to Genesis chapter 3. We're told that because Adam and Eve ate from the forbidden tree, they were cursed. But I want you to look at this close, because Adam and Eve and their descendants, us, are not the only ones that are cursed. I think my crooked teeth probably come from Adam and Eve. But he says, by the sweat of your brow, you will eat the food and your food until you return to the ground, since from it you were taken. For dust you are, and to dust you will return. And that's true. We're constructed basically of the elements of the earth. It's a very insightful statement. But then he goes on and says, but the curse applied to more than just Adam and Eve. Look at this. Cursed is the ground because of you. It will produce thorns and thistles for you. Now, initially, everything was perfect. No mosquitoes, no flies, no ticks, no germs that make you sick, no birth defects, no drifting continents, no eruptions of volcanoes. Everything was perfect. No rocks falling out of the sky. And so what happened? He says, cursed is the ground because of you. It will produce thorns and thistles. Think about it. He's cursing basically the creation, not just the ground. Thorns and thistles apparently did not exist before. Now they exist. The gene pool has been corrupted. Biology has been changed. And so things are going to come into existence that didn't exist before. Flies, mosquitoes, germs that make you sick, birth defects. These things are because of Adam and Eve's sin. In Romans 8, we see that the creation awaits in eager expectation in the hope that the creation itself will be liberated from its bondage to decay. What does that sound like to you? Bondage to decay. Isn't that exactly what the second law says? We're in bondage to decay. Anything we do causes decay. That's the second law of thermodynamics, a physical law. And here we have in Romans almost the same wording applied to the creation, not just to Adam and Eve and mankind, but to everything. So everything became corrupted. And that's exactly what science tells us, isn't it? Let's look at this again. We looked at the Big Bang versus the second law of thermodynamics. Let's see where Scripture comes in there. Okay? It's going to change, I think. All right. So, now we have, here's the Big Bang. Here's the second law of thermodynamics. And we've extended it out a little bit because there was no decay when Adam and Eve were in the garden. They were immortal. They didn't age. By the way, we don't know how long they were in the garden, because if you had seen Adam when he was 1,000,000 years old, he would look exactly like he did when he was 1 year old. He didn't decay. He was immortal. But however long this was, we come to a point in Genesis chapter 3 where the creation was cursed. And Scripture tells us from that point, creation began to be corrupted and decay. What does the second law of thermodynamics, the most sacred of all science laws, tell us? We go from order toward disorder, from perfection to corruption. You see, the second law of thermodynamics and Scripture are in lockstep together. It's the materialistic Big Bang theory that's out of phase. So, biblically, the creation begins in perfection and descends into corruption. Scientifically, we see that the cosmos is observed, and according to the second law, it must be descending into chaos. The self-induced descent from perfection into ever-increasing disorder and corruption required by Scripture is consistent, totally consistent with our scientific observations. The self-ordering rise to intelligence and functionality hypothesized by the materialistic formulation of the Big Bang theory is not. So, mercifully, I'm going to quit tonight. Tomorrow, we'll take a tour of the solar system. We'll look at the planets, and we'll look at the planets from not only orbiters, but from landers that have moved on the surfaces of various planets. And we will compare that with what we would expect from Genesis chapter 1. So, thank you for coming tonight.
Спасибо огромное. Я когда слушаю лекции, подобные этой, у меня возникает такое чувство. Ему нужен будет микрофон, чтобы слышать перевод.
I can
Да,
hear.
лучше ему нужен микрофон. Точнее.
I can hear him fine, so it doesn't matter really.
Наушники.
Okay, thank you.
А сейчас время для вопросов и ответов. Если у вас есть какие-то вопросы, пожалуйста, задавайте. Ну, конечно, вопросы по теме. Не просто другие вопросы.
Напоминаю, говорите медленно.
I can't see you. It's all right.
Перевод последовательно. Не синхронно был.
Где его вопрос? Ну, Дима первый, у него микрофон, у него преимущество.
Спасибо. Наверное, в своей церкви вы сталкиваетесь с людьми, которые отрицают большой сдвиг, миллиардный лет эволюции. Считаете ли вы такие убеждения проблемой и как, в принципе, строите диалог с такими людьми?
Которые отрицают теорию большого взрыва и эволюцию. Do you think that such beliefs are problematic, and how do you communicate? How do you talk?
Could you repeat the first part again? I missed part of it.
Можно первую часть еще раз?
Наверное, в своей церкви вы встречаетесь с людьми, которые отрицают большой взрыв и миллиарды лет эволюции.
I suppose in your church you have people who deny the Big Bang theory and the billions of years of evolution.
Okay.
How do you deal with that?
Well, you know, it's interesting. In the 16th century, there was a big debate about whether the earth was the center of the universe or not. And there were two groups. There were those that were called the stationary earthers and the moving earthers. Someone I'm sure you've heard of, Galileo, he suggested that the earth is not stationary and that it's not the center of the universe. But that the sun is the center of the solar system, the earth and the other planets move around it. This was vigorously opposed by the fixed earthers, who said the earth doesn't move. And this was based on an interpretation of several scriptures. And I'm sorry I don't have them to reference right now, but there are scriptures in Psalms and Proverbs and elsewhere that say the earth cannot be moved, that it's fixed on its foundations. So they accused Galileo of undermining Scripture. In fact, he had to go into hiding. But today, we know without a shadow of a doubt that the earth moves. It orbits about the sun with all the other planets. The fixed earthers had to argue that Galileo was undermining Scripture. But we know today what he said was true. So it's interesting, Scripture was not undermined. Instead, we view those scriptures as an analogy explaining the earth is always going to support life. There are various ways of looking at that. So what ultimately was undermined was not the scriptures, but the interpretation by the fixed earthers. So today we have young earthers and old earthers. And it's almost the same circumstance. Fixed earth and moving earth had nothing to do with anybody's salvation. Young earth and old earth has nothing to do with anybody's salvation. So I've looked carefully and I have never found a place in Scripture which it says I have to understand the creation. I have to confess that God did it. So, is the earth young or old? If we look at the earth around us, there is much data, many observations that indicate the earth is older than 6,000 years. So where did that come from? It came from a bishop in the church a long time ago, Bishop Usher, who tried to take the genealogies and calculate the age of the earth. I think the genealogies were not intended for that purpose. You know, so if people want to believe the earth is young, they can still be saved. But there are ancient cities on earth that are almost 6,000 years old. There are ice layers in Greenland. And the layers are determined to be yearly deposits of snow. Compressed. And you can take a sample, drill a core down through there, and you can count these layers. You can see them with your eyes, many of them. And as many as 60,000 have been counted. So, you know, I don't think it's important to salvation, but here's what happened In the Middle Ages, while theologians were arguing that the earth was stationary, they were drugged kicking and screaming into admitting that the earth moved. Yeah, so while the scriptures were not discredited, the theologians were. And the church lost influence in Europe. So we find ourselves in much the same situation today. I don't know about in Russia, but in the United States, we are losing 7 out of every 10 young people raised in Christian families because they go off to college. They've been taught things like the earth is 6,000 years old. And this belief is simply undefensible. So they find out that what they believed about the age of the earth is not supportable. And then they question everything else they have been taught. So let me just say that excuse me, I'm having a little bit of travel time here where I wanted to go with that. Okay. Well, I can hear where you're, yeah, okay. We're losing our young people over something that is not a matter of salvation. And when you look at the arguments for the younger earth, they don't match what we see. So you must accuse God of creating an illusion for those who want to believe in Him. Whereas the illusion that's talked about in the Bible is for those who refuse to believe. So let me put it this way. Genesis 1 tells us, without any argument at all, God did not create in one instantaneous flash, and suddenly we are like we are today. He created everything in a process of basically 6 steps. The only thing we're arguing about now is the length of that process. And why is that important? And why do we stake our salvation to an interpretation that goes back to about the 1400s, I guess, or so? The good news, I think, is that God accepts us whichever position we take. The bad news is that we discredit ourselves and our influence. The old earth does not violate Genesis.
Понятие древней земли не противоречит книге Бытия.
Okay.
Спасибо большое.
May I ask you? I hope you translate myself after
Нет,
that.
нет, все равно не нужно для записи. По-русски, пожалуйста.
Хорошо. Вы не упомянули,
Не, вы по-русски говорите, пожалуйста.
Вы не упомянули знаменитую формулу Эйнштейна, famous equilibrium by Einstein, about transition of energy and matter, о переходе энергии и материю. E равно mc квадрат. E равно mc квадрат. Вы не упомянули о формуле Эйнштейна E равно mc квадрат, о переходе энергии в материю.
You've gone into learn. Okay.
Я хотела спросить, правда ли?
Let her finish. Yeah, yeah, okay. And
Правильно ли я понимаю, что законы природы, которые мы стараемся постичь, как Эйнштейн говорил, я пытаюсь постичь мысли Бога, что законы природы установлены Богом.
Am I right in understanding that the laws of nature are established by God? As Einstein once said, I'm trying to understand the force of God.
so, do I have it all? Is that all she said?
Yes.
Okay. Okay. I think when you look at his life closely, Einstein was not a true believer. And he probably was being somewhat facetious when he said that. But now repeat the first part.
It was about transition of matter and energy.
Yes.
Since Einstein wrote such equilibrium,
Yeah.
it says so.
Well, Einstein, I don't think was a believer. He was a very intelligent scientist. And he discovered something that wasn't known before, the equating of matter and energy as different parts of the same thing. He said several things that can be taken to be that he was religious, but he also said things that were not. So I don't know how to interpret Einstein. His religious position.
Судя по моим наблюдениям, мне кажется, нам надо проявить милость и позволить нашему профессору отдохнуть, поскольку все-таки 9 часов разница. И перед тем, как мы начали эту сессию, он сказал мне, что сегодня он почему-то чувствует себя более уставшим, чем вчера. Видимо, вчера еще был на адреналине, сегодня немножко больше устал. Если у вас есть еще вопросы, вы их, пожалуйста, приберегите. И завтра, если Господу будет угодно, мы соберемся снова для того, чтобы послушать заключение лекции. Завтра, кстати, мы возвращаемся из глубин космоса на Землю и будем смотреть на Землю как на нечто уникальное. Вот. Почему она настолько уникальна и отличается от всех других объектов во Вселенной. Ну, а на сегодня...